Let's start. So, where were we? Yesterday we have discussed, like we were discussing solid, liquid, and gases, right? Solid, liquid, and gases. States of matter, right? States of matter or physical classification of matter. So, we have discussed few points. For example, in solids, we have fixed shape. We have discussed about shape, right? Then we were discussing size. Size in terms of volume, right? Size in sense volume. Volume is shape is like only of solids, not of liquids and gases. Size is for solids and liquids, but not of gases. But we have seen a statement that at a given temperature and pressure condition, volume of gases is also constant, right? Then we have discussed about density, right? Density. So density is what? Density is mass per unit volume. So mass never changes. Yesterday we have discussed the mass of substance never changes, right? Mass remains same unless until you remove the matter. Mass itself is measure of the matter. If you remove the matter or you add matter from outside, then only mass. So density is what? Mass per unit volume. So mass does not changes as mass itself is measure of the matter. Mass has changed means what? Matter has changed. Matter is either added or matter is removed, right? Okay. So density will remain same for solids and liquids, right? But density of gases may change, right? Why? Mass remains same, but volume may change. It takes the volume of container, so volume will change. If volume changes, then we say density changes. Then compressibility. There's again a word, compressibility. Solids and liquids are incompressible. Solids and liquids are incompressible. I mean, they can be compressed, but even you exert a large force, not force, actually pressure. If you build a large pressure, then you'll see a very small change in the volume, right? So practically we say they are incompressible, right? But gases are compressible. So solids and liquids are incompressible, whereas gases can be compressed to large extent, right? Gases can be compressed to large extent. Now, suppose there's a cylinder which is fitted with a piston, right? There's a cylinder and it's fitted with a piston, movable piston, right? If this contains a liquid, whatever pressure you exert, its volume will not change considerably. It will change, but the change will be very small, right? At your stage, I can say it will be immeasurable, right? But if it was a gas, right, then even a small change in the pressure will show considerable change or measurable change in the volume. So if you increase the pressure, right, if you apply some force on the piston, then the volume of this vessel changes to large extent, right? You compress it, you exert some force on it, its volume goes on decreasing, right? So volume decreases by a large value if you exert pressure on gases. So we say gases are compressible. Is it clear?
Yes, sir.
Okay.
Yes,
Then
sir.
there's a word fluidity. Fluidity. Solids are not fluids. Liquids and gases together are known as fluid. Liquid and gases together are known as fluids because they flow. Anything which flows is known as fluid. Uh, Flow versus move. These are two different things. Huh? Flow versus move. These are two different things. So solids can move, but they don't flow. Liquids actually flow. Liquids do not move. We say liquids move. Liquids flow or gases flow. Right? There's a small difference between flow and motion. Right? For example, if I say a solid is in motion, there's a solid which is in motion. Every particle moves together with same speed. Distance between these particles do not change. Whereas if this is a channel or say say canal in which water is flowing, suppose here there is a water which flows, right? So actually water flows means what? There is layer of water, one sliding over the other, this way, right? It seems like one layer of water sliding over the other, right? So this is what we say is flow. So liquids and gases flow, whereas solids move. Solid move. It's not like solids cannot be moved. If you apply unbalanced force, exert unbalanced force, then solids will also accelerate. They will also move, but they don't flow. It will not happen. You exerted a force on this, so this layer moves up, something like this. This layer moves ahead, and this one remains intact. It's not like that. But in liquids, this layer moves with some velocity, and the bottommost velocity has a nearly zero velocity. Bottommost layer has a nearly zero velocity. All right. So fluidity.
Yes, sir.
Liquids and gases flow. Collectively, they are known as fluids. So fluids means what? Anything which flows is known as fluid. And gases as well as liquids, both of them are known as fluids. Together they are known as fluid. Okay, so these are some small points. One more is that diffusion. 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 Diffusion is what? See, there's a large room. There's a big hall, right? Suppose there's a big hall. One of your friends is standing in one of the corners, right? And you're standing on the other corner. If he opens up a perfume, if he opens up a perfume or sprays some perfume in the corner, then within seconds, even you will smell that perfume. How is it possible? See, how is it possible? He has sprayed the perfume here and you smell it here. Actually, the process is known as diffusion. The perfume bottle has some perfume in it, right? As soon as you open the spray, this gas, which gas? Like the gas which has fragrance. The gas which has fragrance diffuses in the room. The fragrance carrying gas diffuses in the room, gets mixed up in the existing gas, right? So the particles of the perfume, that means the one which carry that fragrance, right, reach here. Why? Because of diffusion, right? So this phenomena is known as diffusion. They diffuse readily. Even if you consider liquid, suppose this is a liquid, it's not flowing, it's still water, right? If you drop a drop of ink, suppose this is drop of ink. If you drop ink in this still water, then the very next moment you will see that ink spreads out. The spring ink spreads out, and maybe after a long time it will be uniformly distributed over the volume of the water, even if you don't stir it. If you stir it, then obviously it gets mixed up, but that doesn't explain diffusion, right? If you stir, if you use a stirrer and stir it, then like this ink uniformly spreads in a very small interval, right? But that is not diffusion. That is, you are mixing it. Diffusion means what? This is a liquid it automatically diffuses, well, spreads out, right? Gets mixed up with the other liquid, right? So this phenomena is known as diffusion. So diffusion is zero in solids. Solids don't diffuse, is more in liquid and maximum in gases. So diffusion does not takes place in solids, takes place in solids, considerable in gas, considerable in liquids. We are moderate in liquid and maximum in gases. Moderate in liquids and maximum in gases. Right? So, see, liquids show diffusion. Liquids also diffuse, but gases diffuse to large extent. Spray of perfume sprayed in a corner of a room will diffuse in this entire room, will spread in this entire room by process of diffusion the very next moment. Right? So diffusion is maximum in gases, moderate in liquids, and zero in solids. Clear?
Yes, sir.
Now important ones. Now these are important ones. Interparticle spaces. Interparticle spaces. So interparticle spaces are minimum in solids. Whatever thing is to which we are saying are particles. In solids, spacing between those particles is minimum. Spacing between the particles is minimum. They are very compact, they are packed efficiently. There is very little gap between the particles. What are those particles? I don't know, but whatever is your constituent particle of solid, those particles are very close to each other. The particles are close to each other, right? So interparticle spaces is minimum in solid. So is minimum in solids. Right. Then is slightly more in liquid. That means there is some space between the particles in liquid. So I'll say moderate in liquid. Moderate in liquid. So there is some space between particles of liquid. Right? And maximum in gases. Maximum in gases. One particle is here, other is here, other is here, other is here. So interparticle spaces, that means space or gap between the two particles, is minimum in solids, nearly zero you can say, is moderate in liquids, and maximum in gases. Is it clear? This is the point which actually you have to which distinguishes between solids, liquids, and gases. This is one of the main points, right? Actually, other points which I said actually are characteristics. This is the property due to which anything is solid or anything is liquid or anything is gas. If you increase the space between the particles, then it becomes gas. If you decrease it to large extent, if you bring the particles very close, then it becomes solid. Obviously, liquid is in between. I'll repeat. Actually, this is one of the properties which actually, due to which anything is solid or anything is liquid or anything is gas. Others are what? Just properties of solids, liquids, and gas. This is one of the main points, right? So I hope this is very clear. Interparticle spaces in solids, particles are very close to each other, right? Are packed, right? Are packed. And in liquids, packing is moderate. That means spaces are moderate. And in gases, packing is very loose. Particles are far from each other. Right? Right now? Hello?
In sponge is there space?
In sponge. You're talking about
Yes,
sponge.
sir.
A sponge is aerated solid. Forget about that. We have like made, intentionally we have made the spaces. No. See, we have created the space in it. We call it aerated solid.
Okay, sir.
Otherwise, solids, see, I'm talking about particles. Even if you consider particles of sponge, then particles of sponge are also very close to each other, like other solids. But actually, a chunk, this must be a chunk of sponge particles, and this is another chunk of particles. There is space between them. But if you talk of particles are very close again. See, something like maybe you have take an example of um, pages. Let us take the example of pages, right? If you consider a new book, if you consider a new book, so new book at the beginning of the year, thickness of the book is like this, right? At the end of the year, thickness of book looks like this. Book at the free end, book looks like this. Have you observed? No. A new book looks compact, right? But after a year, keep on studying. If you see the book after a year, like the thickness of the book has increased. You might have experienced it. Obviously, when you compress it, so again it acquires its own shape, the original thickness, right? Never observed?
Yes. No, sir. Observe.
Yes, sir.
Okay. Now, why this happens? Because air is trapped between them. Air is trapped within it. When you open it again and again and again, like you can say air gets trapped in the one instance only, but some other factors are there. So, due to that, air gets trapped between them. As a result, it appears that volume has increased. Right? Originally, the thickness of the book was less. Right? The same is the case with sponge. In sponge, we have trapped some air. So actually, if you consider only solid particles, they are close, but we have trapped some air inside it. So if you compress that sponge, in order to remove the air particles, if you want to remove, then the size of the sponge will be very less. Okay.
Yes, sir.
Yes, sir.
Okay. So this is one thing. Now, next is force of attraction between the particles. Now, next very important point, force of attraction between the particles. So, force of attraction between the particles is force of attraction between particles. Depends on what? Depends on space, distance between them. See, force of attraction depends on space between them, right? If space is large, then interaction between the particles is negligible. Force of attraction between the particle depends on space between the particles. If space between particles is less, force of attraction is more, whereas if particles are well separated, are separated, force of attraction is less. I'll repeat. Force of attraction is more if they are closely packed, if they are close to each other, right? Whereas if they are well separated, if they are far from each other, then force of attraction is negligible. So in which case force of attraction will be less? Say in solids, liquids, or gas, which one will show particles in which
Gases.
gases? In gases, force of attraction between the particles is very less. In fact, we say it's negligible. Gaseous particles do not interact with each other. Why? Because space between them is more. So therefore force of attraction is maximum in solids, moderate again in liquid, moderate in liquids, whereas negligible in gases. Negligible in gases. We say gaseous particles do not interact each other. What? Gaseous particles do not interact each other. Okay? Is it clear?
Yes, sir.
So force of attraction is next important point, due to which we say that this is solid, or anything is solid, or anything is liquid, or anything is gas, right? Force of attraction itself is a function of space between the particles. If particles are separated, then the force of attraction is less. So in gases, particles are well separated, particles are far from each other, hence there is no interaction between gaseous particles. Right? Clear?
Yes, sir.
Yeah. Kinetic energy and randomness. Kinetic energy and randomness in motion. So, kinetic energy of solids is least. In liquid, it is moderate, and in gases, kinetic energy is large, right? Even randomness is maximum in gases. So, kinetic energy and randomness in in solids is minimum. Solids is minimum and maximum in gases. Right? So kinetic energy and randomness in solids is minimum and maximum in gases. Okay, clear now? To your surprise, gaseous particles, even at room temperature, travel with speeds like 500 meter per second, that means half a kilometer per second. So speed of gaseous particles, even at room temperature, is very large. Is of the order 500 meter per second. That is half kilometer every second. Just imagine, in 1 second, the particle of a gas travels around 500 meter. That means half a kilometer in 1 second, right? Which is a good speed, right? And obviously it increases with increase in temperature. It goes up to several kilometer per second. It goes up to several kilometer per second. And this is one of the reasons they say why moon does not has atmosphere, whereas earth has atmosphere. Moon does not has atmosphere because it could not keep the gaseous particles uh, like trapped due to gravity, right? On earth gravity is more and gaseous particles, so gaseous particle gets trapped, right, in earth's gravity, but moon could not. Why? Because gaseous particles travel with very high speed, and with that speed it could gravity is less obviously, so it could not hold the gaseous particles and they escaped, right? Okay, so these are the points which distinguishes the three states of matter. I hope you have understood all the points and you can, like, you will remember all the points. It's a very easy topic actually. Now, next is one conversion, change of phase. This is next topic, change of phase. Right. See, every substance, whatever you can imagine, uh, can exist as a solid, can exist as a liquid, can exist as a gas. Iron, which you think is solid, if you heat it to high, very high temperature, it will change to